4.05. So talking about graphing exponential functions, which we actually did in class together a while ago. As you can see here, we have x squared, that is our parabola, our quadratic function. We have a square root function, which is kind of like a sideways parabola, but cut off because you cannot have any negative square roots. We talked about this in our Math Nation videos as well. We have a cube root function, and then this would be an example of an exponential function because the x, or the variable, is the exponent, and this is an example of exponential growth. Decay would be starting up high and then coming down low. So here's our first example in page 2. It says, Julie, the biologist, has been tracking the population of dragonflies. Her first count was 223 dragonflies. So this is her first count of dragonflies. It is the initial, it is the beginning. Unfortunately, the population has been decreasing by 3.6%. We call that exponential decay because it is decreasing. The y-intercept, which is also the beginning point, is going to be your 223. The rate of decay, well, let's see, that's 3.6%. But then we have to go ahead and change it to 0.036. Remember, we move our decimal 2 spots to the left, and they just made it negative because we're decreasing, but you can also do 1 minus the rate. It's the same thing as adding negative. Okay, so minus rate is going to be the same thing as adding negative. What is the function that models the dragonfly population? Well, your initial amount would be first. And then we have 1 minus our rate, which was 0.036. So we get 0.964 raised to the power of x, because I don't know what time is going to be in this situation unless it tells me, okay, after 5 years. Here's what that would look like. Starting up here around 223, it will be decay. So if you went ahead and plugged this into a graphing source, kind of like Desmos, you would get something that looks like this. All right, so now we're looking at page 3, comparing functions. So we have an example number 1 here. It says, Gordon, the financial analyst, has been following 2 companies. We have company A and company B. We have 250 times 1.05 to the power of t, and then we have 175 times 0.97 to the power of t. Gordon is going to compare the companies in 3 different ways. He's going to compare them by initial sales, by growth or decay, and then the average rate from 1 to 3 years. So remember the number that's in front, so 250 and 175, those are your initial. That's always what you start at. So as you can see, company A definitely has higher initial sales, so 250, and company B has 175. Growth and decay, well, this is 1.05, so we're taking 1 and we're adding to it. This is less than 1. So we're subtracting from 1. So I'm going to say A is growth, and then B is decay. Company A is growth, and then B is going to be decay because it's less than 1. Okay, growth is greater than 1, decay is less than 1. And then comparing the average rate of change. So when you're computing average rate of change, remember you always want to take from whatever years they're talking about. So year 1 to year 3. So they're plugging in 1, and then they're plugging in 3. Same thing for company B. Then we have to subtract those. And since we're going from 3 to 1, we have to subtract that on the bottom again. So it looks like we have 13.45 more sales per year, and then -5, because remember it's decay, so -5.05 more sales per year. I'm going to jump over to page 5, talking about a vertical, also maybe a horizontal shift. This should look quite familiar to you from what we did back in quadratics, where we have h and we have k. Remember, h is always the opposite. So if you see plus, it's actually negative, meaning to the left. If you see minus, it's actually positive, going to the right. And then k stays the same. So plus would be up, minus would be down. So here's a good example here where you can kind of change some things around and see what happens. So as you can see, h is negative, but it shifted everything to the right. If we're looking at a function like this, you will notice that nothing is happening to x specifically. That means there is nothing going to the left or to the right. There's a plus all the way at the end of my function, which indicates that something is going up. And then horizontal, when something is going left and right, kind of like I was just saying, if you see a positive 2, then it's to the left. If you see a -2, then it is to the right. So it's the opposite of what you think specifically for your h value. All right, so I'm taking a look at page 6. where we talk about another kind of shift where we have a negative exponent. So when our x becomes a negative, what happens is we flip, okay? We don't do a flip upside down like we normally talk about, but a flip across the y-axis. So we have a couple examples at the bottom. So it says Julian is working on a complicated game system. Julian is using this model here to model the difficulty level. What effect would there be if the function was modeled in the following ways? So this first one, you'll notice that there's a plus 15 at the end, all the way at the end after. So that means it's going to go up 15. For this one right here, you will see that minus 3 is inside the parentheses, so it's happening directly to x. I want to think to the left because I see the minus, but remember it's the opposite, so this would be going to the right 3. This is a minus 23 at the end, all the way at the end, so that's going to be down 23. And then we have a negative x, which like we talked about right here, is going to get flipped over the y-axis. Vertical shift, perfect, so up. Then we have to the right, and we have down, and then reflect or a flip over the y-axis. Example number 2, so Gordon opened an account that earns him 18% interest. He puts $3,000 into the account, and then Gordon also took an additional $500 and put it under his mattress. So I'm going to assume that it's going to take whatever graph we have and just shift it up, just exactly by $500, because we're going to have exactly $500 more dollars. So Gordon can add the two functions together. So he has the original here, but then he's just adding on $500, okay? It's going to shift the amount that he made or that he started with just up by $500. Page 7, we have a couple practice questions. So question number 1, we've got 4 different companies, 4 different equations or functions for their revenue. Which company has the highest initial? Okay, so remember beginning is initial. So I have 220 here. I've got 170 here, 320, 180. Definitely going to go with the one that says 320. That's going to be the highest initial amount. And company C. Perfect. And then it just says it would go A, then D, then B in order. Okay. Which companies are decaying? I want to make sure that my base is less than 1. So this is not decay. That's definitely growth. This is growth. Well, there's decay. Less than 1, and this is greater than 1, so that's going to be growth also, so that's going to be company C again. Which company has the largest growth rate? So that's going to be my base again. That's how much my money or whatever we're measuring is going to grow, my sales. The first number is the initial amount. This is how much I'm growing. So 1.20, 1.01, 0.98, 1.05. It looks like 1.20 is the largest, which would be about 20%. All right, and here's example number 2 or question number 2. We have our population here, so we're starting at 20 people. It looks like decay, so 0.94 because it's less than 1. Frog population starts with 14 and increased. Okay, so here's a growth right here. This definitely looks like decay and about 12 frogs it looks like that we're starting with. And here we're starting with 15, and this to me looks like we're doing times 2. Which population has the most frogs to start with? Well, 20, 14, 12, and 15. I'm going to go with 20, so group A. Which populations are increasing? That's less than 1, so decreasing. B says increasing, and D is also going up by times 2, so I'm going to go with B and D. Which company had the steepest decay rate? Well, this looks like it's 0.06, so 1 minus 0.06. So that's about 6% right there. And then if I look at this one right here, it looks like we go from starting at 12 frogs to 9 frogs. Okay, so 9 divided by 12 is going to give us 75% of, so we're decreasing by 25%. So we're going down 6% versus 25%, definitely 25%. And question number 3, we have number of subscribers. So it looks like this is going down, we are decreasing. This one is increasing, and C is increasing as well since it says 1.35, that is greater than 1. Which games have increases in their subscriber number? That's going to be B and C because this is growth going up, and this is greater than 1. Which game has the highest average rate of change from month 1 to month 2? So that's something that we actually need to calculate. We want to take 90 minus 160 divided by 2 minus 0, 98 minus 50 divided by 2 minus 0, and then we got to plug those numbers in here to figure that out. We got to plug in 0 for x, and then we got to plug in 2 for x. So as we can see, the work is here for us. So it looks like game A is losing 35 subscribers per month, game B gaining 24 subscribers per month, and game C, after all the work is done out, we are gaining 82 subscribers per month. So game C has the highest average rate of change. All right, so page 8, practice question number 1. The number of ticket holders arriving at a concert are represented by the function here in hours. The staff for the concert hall is modeled by just 35 people. Okay, the total number of people is going to be however many people show up to the concert plus the 35 people that are working there. Okay, nothing too complicated about that. We're just adding on the extra 35 people working there. So it's going to look like this. Okay, we're just taking the original function and just adding on 35 extra people. Question number 2, the function here. Okay, so 2 times 3 to the power of x plus 2 has been converted to this here. How far and in which direction has the graph been moved? So I went ahead and drew this out real quick so you guys can see what I'm talking about. So on the right, in red, I did the minus 4 one, which is to the right 4, and then the one on the left, I did the plus 2, which is to the left 2. Between any 2 points that you might find between these two graphs, it's always going to measure 6 units apart, because if everything is shifted for this one left 2, to get to 0 is 2 units, and then to get all the way over to the right is going to be another 4. So combined together, they went 6 to the right in order to get from one to the other. Question number 3, so what's going to happen? Minus 2 on the inside directly to x, that is going to be to the right 2. Negative x, that is a reflection across the y-axis. Minus 5 all the way at the end is down 5. Plus 3 on the inside means to the left 3. All right, guys, in page 9, here's a review for everything that was in this lesson. And for 4.05, there is no quiz, but there is actually a project. Please just click project option number 1. The directions are here, so read through each section. You have a couple different options, again, mainly here, so make sure you're reading through those directions. What I suggest that you do once you click on it is you can either take all of this, copy it, and paste it into a Word document. It does let you print it, but that kind of doesn't help you, so I suggest you copy and paste. These are the 7 questions that you are to complete, and these are the points for your rubric. Now, one of the questions that I just wanted to point out before you work through this is that you have to graph all 3 of the equations that you create. I highly, highly, highly suggest you go ahead and go into desmos.com. Insert it back into your Word document that you're working on, specifically for question number 3. Question number 3 is 6 points. So you don't want to lose out on those points. You want to make sure you get that done. All right, guys, so I know this project might be a lot, but let me know if you need any help. A lot of people have done it already. I'm going to try and get next week's video uploaded early so that you guys can see that before you do it. If it might help you, if not, that's fine. A lot of you are doing great, but if you need help, just let me know. And last but not least, what you would do here is you can either have a Word document, you can have a PowerPoint, you could do it on paper. A lot of people have submitted a couple of different things, so there's 7 out of 8 people. I just haven't graded one yet. So there should be a button here somewhere that says submit. You would just find that and you're good to go. You will be done for the week.